Hello, everyone, and welcome to our webinar. Thanks for joining us today. I see that we have still a few people logging in, so we're just going to give them a few seconds so to get settled, and we'll start our webinar for today. Okay, guys, so I have feeling that everyone got a wonderful day. So in the meantime, let me introduce myself. So I'm Jakub Chojnacki, and I'm a digital architect in Billennium, and I will be your host for today. And I will walk you through the some practical use cases and applications of advanced AI architectures, such as those that use large language models or LLMs, and RAG, which are retrieval augmented generation architectures, to boost your business innovation. So I see there are still a few people logging in, so just a few moments. Okay, so I think we're ready to go. So everyone, please remember that this will be an 1 hour long session, but we will have a time to answer some of your questions at the end of the presentation. And for this, we will have a dedicated chat box that you can post your queries, and feel free to drop all your inquiries on the topic and share your experience. One of our experts will take care of all those inquiries during the webinar. And if at any case we won't be able to answer any of your question, we'll make sure to get back to you and share the answers via mail. And in addition to this, the webinar is being recorded. So all the recordings will be shared to you guys. So don't worry about missing anything or any topic. It will be recorded and sent. And that said, let's start to our main topic of today, and let's discover how to adapt your business using some cutting-edge technologies to change your data-driven decision-making. So let's start with OpenAI capabilities. So everyone, I think, heard about the ChatGPT, and I think most of us are really impressed of how this system can make innovation. But what basically is this ChatGPT, and what is it different? And so in the past, when we were to use natural language processing, before the GPT models in a older approach, how it worked is basically that instead of a single big model that was able to do many of the tasks such as sentiment analysis, intent recognition, summarization, Q&A, and style transfer or whatnot, we were given smaller models that their job was to make or do just a single type of task. So we could have a dedicated model for sentiment recognition, we had a dedicated model for intent recognition, and so on and so forth. And our job was to basically connect those models together in some chain in order to make the system work. And the biggest issue with that type of models was the chaining part. So you can envision that if we were to build 4 models in a chain, and even if we had 3 models out of 4, that its performance would be near 90% or 100%. and the one model out of those four would have a bad performance, then the entire chain would be as good as the weakest component. So even though the majority of our models would be great, the one model would be sort of a big problem, and it would be really hard to develop solution reliably given many smaller models and chaining them together, because it would have problems such as this, that the worst model would basically make the performance of the entire chain. And now, in a GPT era, there is one foundation model, the big model that can do all of this, and its performance is consistent across all those tasks. So it's as good in the sentiment as in the intent recognition and Q&A. So there is no part of sort of chaining. There is a single model that can do many things as we ask it to do. And the input for this model is basically as a single input and single output, and it allows the model to basically make the task at hand. And what are the most known core capabilities of such models as the GPT? So of course, this is a conversions and chatbots, the content generation, summarization, data analysis, and content search. And I think all of us have been in a situation at which we've used ChatGPT or GPT models to do one of many. So conversations are basically just a chatbots. So you can ask questions and the system will be stateful. So it will have a memory, which allows you to remember the past questions and answers. The content generation is basically ability to generate new pieces of information out of the existing memory. The summarization is a task that allows you to have any number of documents or text or any other domain specific information and make a concrete summary as a compression. The data analysis basically allows you to get to have a some kind of data like Excel file or Word file or any other file and make an analysis based on those data. And context search is the most, I would say, recent advantage of the capabilities of such systems that allows you to search your data and retrieve the most important informations and chat about them. And of course, when we are talking about GPT models and generative AI, I would have to say that all the possibilities comes from the thing that we've got those models launched in a cloud services such as Azure One. But of course, Azure is not the only provider. We can always use the AWS Hugging Faces or Vertex AI. But for now, let's focus on the Azure one, as this is the main one that launches the hosts the OpenAI services. And basically, inside the Azure OpenAI services, we can find all the necessary pieces to build our ChatGPT version of the system. So we've got a GPT models, so those that allow us for tasks such as summarization or content generation, the codex that allows us for generating a code or understanding code, DALI for image generation, and if you were to basically connect all those possibilities and add some pieces that would allow us for searching our documents, we would sort of end up in a ChatGPT application. And we'll focus today on how to achieve sort of a ChatGPT that can talk to our files. And so I really like to envision any OpenAI or generative AI project as a cake. So if you were to say what are the main building blocks and what are the additional layers for the project, So the first one, the main base layer of our cake, the foundation, would be an OpenAI model. So such as GPT model or a Gemini model or Llama model, any large language model. It would be our base layer. The next part is about making the large language model a little bit better in the context of our task. And here we can use either fine-tuning or semantic search to enhance the precision and the relevance given our data or given our feedback. And the last piece is, and the cherry on top is the reinforcement learning. So if at any point we would like to to create a feedback loop for our system and describe whether the answer created by our system is correct or not, we could allow the system to continuously improve given this technology. And we'll go through all of this in a moment, and I will describe what are those techniques and what is the relevance and when would you like to use one or another. But first, let's start with some use cases. And so the most common use cases for the usage of GPT and generative AI in financial sector would be chatbot advisors, so the systems that can provide a personalized financial advice, such as how to invest your money or how to make your tax plans and whatnot. The personal finance management assistant, so a little bit farther, the system that would either keep track of your expenses and give you some advices of how to make your personal finances reach some certain goal. And the last one is, of course, fraud detection and prevention. So the system could analyze the financial data patterns and identify the anomalies or any flows given some certain informations coming from the output, and process the input with respect to the output from the system, and give you an information whether certain things are the anomaly or any other issue in a real time. In the automotive sector, it's pretty common to add generative AI to a virtual car assistance. So all the systems that can make any contextual informations about the conditions, about the problems with your car, in engine, or any advices given readings from your sensory data. This is where the chatbot systems thrive. The customer opinion analysis, so the systems that can basically read all the opinions on the areas, and given those informations, they can scan the network for possible customers and prioritize some over another. And of course, the last one, the cutting edge, is the support for autonomous cars. So you can envision the situations at which you could aim for driverless navigation, and you could, using generative AI, create a synthetic visualizations or synthetic simulations of the roads, and train your networks using the simulated video, for instance. When it comes to a medical sector, there are, of course, the visual medical assistants that can inform on a various conditions, that can inform about the symptoms, medications, and possible procedures, and they can have access to the medical history of a patient, and can in a fast manner, they can search for certain symptoms and medications, and they can give a summary of, for instance, what kind of medications were the user taking in the past. And this is basically related to a medical visit summary generator. So here is another case at which, given the history of the clinical notes from the hospitals or for the clinics, you can have a summary of what have happened to your patient in the last few years or any other history window frame. And the last one, of course, the most cutting edge, is the medical clinical simulations. So in the internet, you can find many of the viral videos at which certain, for instance, surgeons can train their skills on a virtually created organs, such as hearts, livers, and whatnot, and they can proceed with surgery on a virtually created environments, and this is pretty awesome. And so, to be more concrete with the projects we have done in our company, I have chosen 4 which are the most common and that are having the highest impact on a innovation right now. So the first one is the financial email analysis. So you can imagine a situation at which you've got a stream of emails and you would like to semantically categorize which email should go into which category. So you may search your emails, for instance, for a business category or for a medical category or any other category. And given the content and the metadata from the email, you can categorize this email to either mailbox, and you can send this mailbox to a concrete person, and you can also create a possible response to this email and ask the person whether this response is correct and he should send such a response or not. Flight information chat system. That is a system that would be mostly concerned about utilizing an internal extensive database. So in most flight systems, for each vendor, there are different versions of software, for instance. And it's pretty cumbersome to find the correct version and correct policy for a given case. So if you would like to reschedule your flight for LOT, the Polish Airlines, the operator from a LOT would first have to find the correct software, then the correct version, then it should check for a policy that allows you to reschedule your flight and whatnot. And this is pretty hardcore case at which the operator has to go through many files, many documents in order to fill a single document that allows you to reschedule your flight. And in those systems, how it works is basically you input your query for changing to rescheduling your LOT flight from Wednesday to Sunday. And what it does, it automatically searches for the policies, it searches for the versions of the system and whatnot, and does it automatically for you. Only you as the operator has to accept whether this action is correct or not. Medical triage prioritization. I will go in the next slide through this part because this was the most cutting edge use case of Gen AI. And the last one is magazine content summarization and generation. So again, you can imagine that in your database, you've got extensive amount of documents that are text and images and any other domains. And what you would like to do is you would like to search for a given search term. And then you would like to find the most relevant magazines, check whether those most relevant magazines fill into the evergreen content or into a Google Trends. in order to ensure that your magazines are trending or not. And given that, you would like to step by step ask your Gen AI assistant to write a new magazine given some information from the internet online. And so let's get back to this study for the medical triage, because this is the one that we have generated metrics, and this is the one that had a real impact on in a world. So the case study is that we would like to build a medical AI assistant that operates in US and in a company that owns about 100 ambulances. And this company receives about 10 to 20 calls per hour. And due to the fact that humans are prone to emotions, we are given the task of whom should we send the ambulance. And we are only given voice in real time. And so the medical triage consists of more than 4 categories, but in order to make it concrete, let's say that we've got only 4 medical triage priorities. And the green one, the easiest one, is just a routine. So this is the person that do not require the ambulance in the urgent. And on the highest top of the scale, we've got the red, the emergency, and this is a situation at which the person has a life-threatening medical condition and has to receive an ambulance at the moment. And our job is basically to help the operator make a decision so to ensure that the emergency, the highest scaled cases will have a higher survival rate. And the green, yellow, and orange will stay at the same percentage rate. So without making orange, yellow, and green worse, we would like to make red better. And the system worked the way that first we were transforming the voice to text in a real time. So you can see on the left there is a operator and caller summary. So you can see that the operator gets the emergency call from a caller. The caller informs about the situation, that his friend is experiencing severe abdominal pain, and the operator is going through the triage questions. And based on that, our system is, first of all, creating a caller status. So this is a summary that is done using a GPT model. So the GPT model is making a summary of most important points, such as what is the caller's friend status, what is the pain type, what is the location of pain, and all the important parts. Then it's making a caller sentiment analysis. So given the voice recording and the text, it creates a diagram of sentiments over time and chooses what are the most top-rated sentiments. So we can see that, for instance, here, top 4 caller sentiments were concerned, worried, anxious, and cooperative, right? And given that, the system is able to make a priority. And for this case, we can see that the priority is set for the urgent, as this has the highest value. And all those 3 structures, the caller status, priority, and top 4 caller sentiments, are presented to our operator that later decides whether the priority is correct or not, and puts the caller into a queue. So either the caller is given a ambulance, or he is given a place in a queue to wait for the ambulance. And so the case study resulted in the fact that before the AI emergency casualties, the survival rate for the red class was about 7%, so it was pretty small. But after the implementation of the generative AI into the system, the red class survival rate was about 13 percentage points. So we can see that we had a improvement of over 6 percentage points from the start of the project without hurting other classes. And this is what OpenAI can bring us, and how can the OpenAI and the generative AI make the world better. And so the question now is, well, how could you build one yourself? And so the main idea behind building systems that can operate with generative AI is simple. And this is the example of how you build a system that could retrieve information from your database. And it could decide on summarization, on recognition or generation and whatnot. So if you were to go from the leftmost part, we've got a data storage. So we've got all our documents, and we've got some Azure Form Recognizer. So the system that can perform some OCR or any other instruction to make your documents searchable and in a digital format. Then we've got the first generative AI component, which is embeddings model. And the embeddings model is a model that allows you to move your text format into vectors, because all the AI or Gen AI systems require numbers, not text. This is the most important step in the system. Next, we've got some database, or we can use a standard database, or we can use vector database if we are more on a top. And then what happens is that if the user, from the top right perspective, will ask some question, so there will be a user input, this input will be again invoked through the embeddings model to again create the vector representation. And then we would like to compare the vector representation of user input to our documents. And the most related documents will be retrieved from our database and put into the OpenAI service prompt passage on the bottom, and our system will make certain operation given those documents. So for instance, it will summarize or create a new document based on our previously fetched ones, or will make some action that we will ask him for. And at the end, we can put the output into our web application or any other place that we would like to source to our user. And what are those embeddings? Because I have said that this is the most crucial part of the system. And so basically the embeddings are the OpenAI embeddings are the models that convert text into a numeric vectors. So as we can see, if we were given a word such as cat, kitten, dog, and houses, and we were to create embeddings, those numbers for each of them, then later we would be able to create a diagram that we could put our vectors in. And the awesome parts about this is that, as you can see, the mostly semantically related words are close to one another. So cat and kitten are pretty close. Cat and kitten are closer to dog than they are closer to houses. And what it allows us to do is that at any case, if there would be a new entry to our system, so if the user will ask about apartments, then this query will most likely land close to our houses. So we would be able to fetch all the documents from the houses and ask our system to do something useful with those documents. And the same happens with all our documents. If we are able to build a numerical representation for our documents, then we are able to later semantically search for the relevant context in our documents. And this is a pretty powerful technique, which is known as retrieval augmented generation. And of course, if we would like to go a little bit deeper, then we could ask ourselves, how does the system see the similarity of the words? And basically, we can see that the most similar words are yellow, and we can see that the similarity matrix on the left says that if we are looking to a mostly similar words such as food and drink and fruits and vegetables, then they are pretty similar. And if you were to compare the food and drinks into body parts, these are rather not similar. And this is how the system sees the words given the vectors. And this is how the semantic similarity matrix is drawn. And based on that, we can sort of debug our system and look how the generative AI sees the world we see. The next part of our icing is the fine-tuning with OpenAI. So now, instead of feeding our system with documents and searching our documents in a database, we would like to fine-tune or adapt our GPT model to understand our files off the shelf. So now, instead of first searching for the relevant documents and putting those relevant documents into our GPT model, we would like to train our GPT model with the documents. And so this is pretty expensive process when it comes to the fine-tuning of such big models. And it's done not often. It's rather a situational strategy for making our system understand some information that it has not been trained for yet. So, for instance, in the companies, we might have our values, right? And I'm sure that most of the GPT models do not know the values of our companies. And so what we could do is we could fine-tune the GPT model to understand the values of our company. And later, we could use that model, for instance, to suggest the best manager or the best person for current career path, right? And this is what the fine-tuning allows us to do. And so basically fine-tuning refers to the adaptation of the AI model that has already been trained to perform large amounts of tasks such as summarization, sentiment analysis, and content generation. But we would like it to learn a new specific task, such as understand our company values or our company language or anything that it has not yet been trained or had not been given access to, using some smaller task-specific dataset. So now we do not have to train it to make a summary, to train it to make a sentiment analysis, because it already knows how to do it. We would like to train it for a task that has not been ever exposed to. And GPT model fine-tuning or any generative AI fine-tuning is basically done using mostly the historical data. So if you have any database of your documents that relate to some summaries and some questions and answers, and you would like your system to understand and answer those questions given this knowledge, you would like to basically feed it this data and assume that the system will be likely to answer given your data. And the last part is the reinforcement learning, so the cherry on top of our cake. And basically, if at any point you would like your system to learn continuously. So you would like to guide your system whether it's made a response correctly or incorrectly. So for instance, giving a thumbs up or thumbs down to your system, then you would like to use reinforcement learning. And how it works is basically as we could observe having our children. So for instance, if you had a child, which would be our chatbot, if at any point it would have a bad behavior, we would give him an advice. So this would be a painful information for him. So he would need to adapt to avoid making this bad behavior. And alas, if our child would make a good behavior, then we would give him a reward. So later, he would be more into making this good behavior again. And the same is with chatbots. If at any point our chatbot would give us bad response, then we would basically give it thumbs down, and it would learn to not make the same mistake again, given similar question. And if at any point your question would be treated properly and you would give it a thumbs up, then the system would be most likely to give you a response such as that in the next time. And so now we are getting to a last part. So the building this retrieval augmented generation systems. So the ones that can go into your database, they can allow a user to ask questions, retrieve the most important documents or chunks of documents or any kind of media, and allow you to chat about those documents and only about those documents. So if you were to give the system a document about your company policies, and at any point if you were to ask about, I don't know, Elon Musk or Coca-Cola or who is the president of the US, this system would say that I'm so sorry, but I cannot answer the question. It is not related to a document at hand. So it won't hallucinate. And how it works. So the retrieval augmented generation consists of 3 steps. The first step is the ingestion. So given your documents in PDF format or in the Word format or images or whatnot, first of all, we would like to chunk them. And this is due to the fact that your documents might have different number of pages, different number of words. And the generative AI works the best when you have the same number of words or tokens per chunk of information. So first part is just chunking your documents. Let's say each chunk is just a single page of your document. And then we would like to each chunk to convert this into an embedding space. So now you can envision again that all the similar chunks will end up in a similar place in a box. And those embeddings and chunks along will land into a vector database or an index, which allows us for searching those documents. And now, when we've got the index built, so we've got the embeddings and reference chunks inside those, we would basically be able to ask a query. And this query would first go into an index to find top K most relevant chunks of your documents. So given your query about what is the most common policy in my company, we would have a top K most relevant chunks about this question, and those top K chunks would later end up in a large language model that would be given this context, those chunks of documents, and a query from user. So for instance, my query would be, what are the most common policies in my company? And our system would be given chunks of documents for our policies, and it would basically make a response of summarization of those top K documents given user query. And the state of art. So if you were at any point implementing such a solution in your company, then you would most likely end up with two of the most popular technical aspects, which I will briefly go through. So the first one is the expansion with multiple queries. So basically, when the user asks some generic question, the first rule of generative AI is that we do not trust user, right? So we would like to pre-process the query and then expand the query. So if I were to ask a question that what is the best policy, right? So this is not the most contextful information I could ask my system. So my system would pre-process my query. So it would take all the information it can from me. It would expand my query. So it would add some more context to it. It would rewrite my query a few times. And only after that, after it would have the most context it could from the user, it would only then ask the vector database or the index for the result. And this mechanism allows most of the queries to search for a concrete and the best outputs, because it often happens that you might ask some general question, and given your general question, the answer from the system might also be general. And we do not want that. We want our questions to, even if they are general, to make them as contextful as possible by expanding our query with multiple other subqueries, and only after that making sure that we retrieve the most concrete examples of our documents and give them to large language model. The second one is the embedding adapter. So what it does, it's in a cheap way will alter your embedding store. So you can imagine a situation at which you've got a 1,000 documents, let's say, and let's say that 200 of them got out of date, right? So you wouldn't like to search for those documents at any point, okay? So the first idea is that, well, you could either remove the embeddings or you could rebuild the embeddings. And the problem with that is that if you were to remove the embeddings, you would most likely make some structural damage to your database. And if you were to recreate the embeddings from scratch, it would be a cost for you, right? Because every query to your generative AI model costs some money. And the easiest approach for that is to create an embedding adapter that would basically say that if the user query is asking about certain policies, then please cut off all the embeddings from this part of your embedding store. And this is the simplest part, and it won't damage your structure, because this is all mathematical operations. This is all the vector multiplication stuff. So all the mathematical properties of the systems are held. Only the part that your older documents will never be searched again with this adapter. And this is pretty awesome feature, because if at any point you would like to get access to your older documents for any reason, then you would only need to remove the adapter and you are back with your old files. Pretty awesome stuff. And so to summarize, the content of the building your own chatbot that can talk to your files and it won't hallucinate. That's pretty important. Then, first of all, going from bottom up, you would like to make your unstructured data pipelines, right? So you would take all your files, you would read them, you would OCR them, you would chunk them and make the embeddings for them. And you would put all those embeddings and chunks into a vector database and assign an index for that. And next, going to a topmost part, if the user will be asking a query, then first of all, we will pre-process the query, okay? So remember, guys, we want, we do not trust the user. Always pre-process your queries. If you can take any information from single sign-on or multi-factor authentication or any kind of certificate from a user, whom he is, what are his devices, everything, and pre-process this given this step. It's always useful. It always works. Next, we would like to expand our query. So given our general query, we would like to expand this query of as much context as we only can. Next, we would make a retrieval or re-ranking. This is optional step. At any point, if you are having too much compute power or too much money, you would like to basically make a re-ranking. So you could use your large language model to think whether the retrieved documents are correct and relevant. And for instance, you could compress some information or expand some information, or say that certain chunks are better than others. Pretty awesome stuff, but not necessary at first. Next, you would like to make a prompt engineering. So basically, you would like to ensure that your system, your large language model, understands its role. So you could say that, hey, large language model, you are an assistant for my company. Your job is to answer queries only given the context given from the previous step. And please ensure that you are a professional entity and give your answer with concrete format. So maybe you would like this to be a concrete answers, or maybe you would like it to be a answer with bullet points, or however you would like it. And then there is a generation part. So the large language model, given this prompt and the context, will generate the answer in your given format. And the last part is the post-processing. So given your initially pre-processed query, you can wrap your answer into any format. So if, for instance, your system requires JSONs, or maybe you would like to have a PDF file or CSV or Excel or whatnot, you can then take those generated pieces and put into a single response. And from a bottom perspective, there's a structured data pipeline. So it's pretty common to use any kind of monitors for such systems. So for instance, if you would like to monitor how much cost does your system generate per token, then you would basically use the monitors to ensure that you are not getting your money out of hand. Or maybe you would like to check what is the latency of your model, because maybe your users are getting frustrated because your system is too slow. And so monitors for such systems are pretty awesome. And using any kind of real-time monitors is pretty necessary in such cases. And so let's jump into the Q&A session, because I can see that I think we've got a few questions. Okay. Okay, so the first question is, in the case, I wonder if it's common to fine-tune large language models overall for companies wanting to leverage pre-trained models. So it really depends on the use case. I would say that it's not that common to fine-tune large language models, but it happens. I would say that 3 out of 10 projects with generative AI requires fine-tuning of large language models. And these are mostly the situations at which, let's say, you would like to extract some pretty concrete information. So let's say that your job is to, given the context, you would like to have a filter that would extract the document and give you the list of latest policies from all the files. And that is the way you could find your large language model. So instead of only giving you answer about the single output of your policies, to also give you a bullet point of latest policies and what he knows about that. And most of the cases for large language models is now done also using adapters. So there's a pretty famous library called TRF on Hugging Faces, which stands for Transformer Reinforcement Learning library. And it's pretty awesome because you can fine-tune all the latest models such as Llama 3 or GPTs or whatnot. And it results in pretty awesome results. Was the geolocalization used in the ambulance project? I see. So this is a pretty good question because the answer is that it was used. The geolocalization was a part of the system. So if we were to get back to the ambulance problem, so right there. So the geolocalization was not using the like typically Google information like Google Maps or whatnot, which would be pretty useful. It had a knowledge of the geolocalization of the system, so it was scraping the latest information from a Google site. And thus it was a additional stream to put a priority or put a higher or lower priority for the patient. So yes, the geolocalization was one of the crucial parts added, but it was not like the main pipeline for priority. It was a single addition for the project. And of course, I think it could be even further improved to use like real-time Google Maps data of traffic. So, do we have any other questions? Okay, so I see that there is no more questions, but if at any point you would have any questions related to our projects, or you would like to ask about certain details about the projects or the technology, please feel free to contact us. We will gladly give you all the informations and answer all your inquiries. And of course, the webinar has been recorded, so it will be available for you at any point. Please feel free to contact us. And thank you so much for being with us today. And I wish you a great week.
Billennium. IT for people. People for IT.